Hello everyone and welcome to the Game Engine programming series where we write a game engine from scratch. We have been working on the graphics part of the engine for the most part of the year now, and although it's been a lot of fun for me to do so, I kind of feel the need for a break from C++ side and would like to spend some time working a little bit on the editor side again. And the reason for this, other than that I like to code in C# as well, is that we need to prepare the editor for importing assets for the engine to consume. So, since I didn't work on the editor for some time now, I made this warming up video where we work on the ability to switch between game projects and fixing the issues that we encounter while doing so. In the next couple of episodes that follow, we'll work towards having a basic content browser and importing geometry assets from FBX files. Switching projects is an action that can be triggered using a hotkey combination or by using a menu item. Let's do both at the same time. I'd like to add the menu in the world editor. We could also add the menu to the main application window, but I think that would become confusing when we add other kinds of editors which have their own menus. First, I'll add a new row in the world editor XAML file where we put our menu bar. I've got to move the other two rows down first. Then I'm gonna go ahead and add a menu with some placeholder menu items that are rather typical for all applications. We can also disable some of them just to have an idea of how they look. Although looks aren't the thing to worry about right now, I'll come back to it later in a blue episode. Under File menu, we can add other menu items. We would like to be able to create a new project or open an existing project, as well as save the currently opened project and exit the application. We also use a separator to group the menu items. Cool. Now we have a menu bar on top and we can use it in the same way as in other applications. Let's format this button bar a little bit so it's not all crammed up like this. That's better. Now we need to implement the thing that should happen when we click on a menu item. Fortunately, there are some predefined application commands that are specifically intended for opening a new or existing item, saving and closing the application. We can attach a function to each of these commands, which will be called when that command is executed. I'm not going to use the application commands.save because we already have a save command in our view model and we can simply use that one instead. For the remaining commands, I'll hit F12 a couple of times to generate the methods, which can be filled with whatever we want to happen. To close the application, I just call the main window's close method. To open a project, we first unload the current project. Then we set main window's data context to null and close it. Remember, main menu's data context is the current project. I'll explain why we do this in a minute, but first let's attach these commands to our menu items. As you can see, when I click on Save, the project is saved as if we pressed the Ctrl+S key combination. Also notice the hotkeys that automatically show up on our menu. Now when I click on Open Project, the application closes, which makes sense because that's what we told it to do. To prevent the application from closing, we somehow need to signal the main window about the fact that we only want to open a project. And that's exactly the purpose of setting main window's data context to null. Here in onMainWindowClosing method, we can check if the data context is already null, and in that case, we cancel the application shutdown by setting e.cancel to true. Then hide the main window and open the project browser dialog. Next, if the data context is not null, we know that the user opened a project and we can show the main window again. Checking data context here is not strictly necessary, since project browser dialog will shut down the application if the user didn't want to open a project. Now when I click on Open Project, we are presented with the project browser dialog where we can open or create a project. Trying to switch projects too fast will crash the Visual Studio automation part of the editor. This is because we are calling these methods asynchronously without using any data synchronization. I'm going to fix this class later in this video, but for now let's continue with what we are doing. We still need to implement on new project method here. Since it also opens the project browser dialog, we can almost use the same code as Open Project method. The only difference is that we would like the project browser to switch tabs, such that Create Project tab is visible. To get that working, we can add a static Boolean variable that we set to true when we want to go to the Create Project tab. Then in Project Browser dialog loaded event handler, we can check if we want to switch tabs, and Bob's your uncle. And there you go. We just created a new project. Of course, we need to clear the log from the previous session, but right now we have a bigger issue here. As you can see, the editor is sluggish and non-responsive. That's because we still have some really bad code in our Visual Studio Automation class, and that's what we need to fix right now. Let's start by moving some build-related code from project class to Visual Studio class. I'll move the build configuration enumeration, followed by a couple of fields and methods that make use of it. Looking at this code, we immediately see that there are no failsafes in place for when _vs instance is closed or somehow failed. Of course, we need to set it to null when we close Visual Studio, but it can still be in use somewhere asynchronously. So we need to do two things. Make sure that failures are handled correctly and make sure that _vs instance cannot be used by different threads simultaneously. As you can see here, we have a naive implementation that tries something 3 times and then gives up. Also, it suspends the thread for 1 second each time, which might explain why the UI got sluggish. I'll start with handling failures when we call Visual Studio functions. As I mentioned in the video where I first wrote this code, the correct way of dealing with COM failures is by using something that's called a message filter. Roughly speaking, it's a way of intercepting COM messages to see if the call to a COM server was successful. In our case, Visual Studio is our COM server and we need to find out if the call that we made couldn't be handled and we need to try again. To use a message filter, we need to import and implement the iMessageFilter interface. An example implementation can be found on this website. When we implement an IOLE message filter interface and register it, the retry rejected call method will be called when the COM server rejects a call. If the reject type parameter is server call retry later, then we know that the server is busy, but it's okay to try and call it again later. Let me actually just copy and paste this code into our file. I'll also grab the implementation and change it a bit for our use case. There are a couple of constants that we can define here instead of using their value directly. That makes it easier to understand this code. As I mentioned, we need to register our message filter. To do so, we need to import and call co-register-message-filter function. Later, we can unregister the message filter by calling the same function again, but this time pass null for new filter parameter. Let's also use the same names for these constants as defined in the documentation. So now when we are called back in retry rejected call, we can check if the COM server wants us to try again later, and if so, we will tell it to retry after 500 milliseconds. Otherwise, we tell it to cancel the call. Simple, right? As the old saying goes, if something seems too good to be true, read the small letters to see what's the catch. Looking at our code, we can see that we are calling the functions asynchronously, which means that they are being executed on different threads. However, looking at message filters documentation, it says that it can be only used with single-threaded apartment threads. Oh well, it was fun while it lasted. Let's remove this code. Nah, just kidding. Here is where Mekamish stepped in to help me with a simple and elegant solution. He suggested to spawn an STA thread every time we want to make one of our calls and register the message filter for this thread. So we have an action and we run it on an STA thread. In the threads function, we register the message filter, try to execute our action and catch any exceptions that might have been thrown. Finally, the message filter is unregistered by calling the revoke method. Then we can set the thread apartment state to sta and start it, which will immediately run our thread function. Using thread join function, we can wait until the action is done. Now we can call anything that could require a retry using this new function. That's pretty much everything that has to do with _vs instance that could take some time to complete, such as saving and closing the solution, or opening the solution and adding files to it, and so on. I'm also happy to get rid of these noobish for loops, all thanks to Mekomish. So basically, our methods partially or entirely become actions that will be called on another thread with a single-threaded apartment state. Then when the com server sends our application a message, it is intercepted by the message filter and handled properly. Here in build solution, I'm trying to put the right part to be run on the sta thread. Remember, we also changed the way we get the build configuration. So it's now an enumeration instead of a string. And that's all of them, I think. One issue that remains is the fact that when we call execute command to build a solution, it will return immediately, even though Visual Studio would still be busy building the solution. So we need to wait for it to finish first. With this implementation, the only way to know when Visual Studio is done building the solution is when onBuildProjectConfigDone event is triggered. Therefore, we need to block this code until onBuildSolutionDone event handler is called. To do so, I'm going to use a ManualResetEventSlim, which is part of .NET Threading namespace, and it kind of works in the same way as Win32 events. Using false for constructor parameter will create an instance that is not set. So when execute command is called to build the solution, we can wait for the reset event to be set. And then we call reset for the next round. Now we can set it in onBuildSolutionDone event handler, where we know for a fact that Visual Studio has finished building the solution. Of course, the condition is that this event handler should be called at some point. So if Visual Studio would crash while building the project, which is not improbable to put it mildly, then we would be dead in the water. Unfortunately, I don't have the solution for that one yet, but I'm sure we will eventually figure it out. Okay, this is all for now for handling comm messages and errors. The second issue that we had is the lack of synchronization in calls to Visual Studio. Here we can see that we could close the project while we are building the game code, which would cause great confusion for our automation class. The fix for this is simple. We just need to serialize our function calls using a lock. Therefore, I'm going to make all methods in Visual Studio class private and append underscore internal to their names. And then I simply call these from within a locked scope in a public method. So after adding a underscore lock object and renaming the methods, we make sure to call the private methods to avoid deadlocks. Then we create the public methods, lock them, and call the private methods from here, passing them the same parameters. That's all for synchronization. Now let's fix the errors in project class and do a little code cleanup as we go. For one thing, I'll change DLL in variable and function names to use capital letters. Here we also clear the log when we close the project, so if we would open or create another project, our log panel would be empty. And then I'll use the build config enumeration instead of config name string for Visual Studio calls. Now let's fire it up and see if everything still works. Looks like it works just fine. We are now able to switch projects or create a new one without any conflicts, which is great. I think we have got some time left to fix another issue that was brought to my attention actually quite a while ago, also by Mekamish. And to show you what the issue is, I'll create a new game script and I'll call it hello.kitty plus papa, which is totally fine as a file name. As you can see here, a header file with that name is fine. However, we run into all kinds of problems in the C++ code itself, because obviously that wouldn't make a valid namespace or class name. So we need to find a way to prevent the user from typing in these kind of characters. We already do validate the script name, so we need to change our validation. Of course, we could filter out all characters that we would like to disallow, but that list would be quite long and we could also forget to put in every character that would cause problems. Instead, we want to check if the script name is composed of a limited set of characters that would combine to make a valid namespace or class name. And those are the alphanumeric characters and the underscore. I'm going to use regular expressions to figure out if the script name contains only these characters. So, if the script name matches with any other character that's not one of these characters, then we will reject it. Let's do the same with the project name, since we have the same issue here as well. And since we are here, let's also fix another issue, which is caused by me hardcoding the path to Primal Engine in the gamecode's C++ project file. Here you can see the engine path as z:/primal, which works fine until someone moves the engine to another location. A better way of doing that is to use the environment variable, which is set when we run the editor for the first time. That way, when the engine is moved to another location, the editor will ask for that location again and update the environment variable. So all we have to do is to use this variable instead of hardcoding the path when we create a new project. And that's all for today. Now we can't create projects and game scripts with invalid names. Also, the path to the engine is now dynamically determined using this environment variable. Hopefully, there was something new for you in today's video. As always, thank you for joining me, and I'll see you next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!